Hello everyone, welcome to Study with Sri. Today we're gonna discuss 2025 IMAT Physics questions. 25 physics questions, it's similar to mathematics questions. All these questions are tested. They have tested a lot of fundamental core concept. So if you are clear with your core concept, it's very easy to approach. But if you have a dilemma, or else you study some physics concept and you are not clear with that, and there will be a dilemma and you won't be able to choose the correct answer properly. So always make sure when you are studying something, try to understand the concept clearly, and then you can increase your speed and it would be very easy for you. So now let's dive into this question. So first question, two cars A and B are moving in uniform rectilinear motion with speeds of 120 km per hour and 80 km per hour. If at the initial moment A is 500 meters behind B, after 1 minute what happens? So this question, when you're approaching most of the physics question, make sure that you sketch the diagrams. If you sketch the diagram, there are two benefits. One thing, it is easier for you to visualize, and the second thing, you don't want to reread it again because you have the picture, so you don't want to keep on reading it again. So it saves the time as well, because you are reading again it's going to consume time. So make sure you sketch the diagram. So this question is all about the linear motion. This question is about linear motion. Along with that, it's also talking about the relative motion. So let's try to understand what is the relative motion. The relative speed. This question is all about the relative speed. The relative speed is the speed of an object as observed from another object. Let's see with an example. In this picture, you can see, now if you are someone who is standing at here, if the car is moving with 100 km per hour, for you, it appears like the speed appears exactly 100 km per hour. Imagine you are standing on the side of the highways. When the car passes at 100 km per hour, to you its speed is exactly 100 km per hour. Now imagine you are in the car, you are driving the car at 80 km per hour speed, and another car at the same time, and another car is passing you. The same car which is having the speed of 100 km per hour, is it passing you? If it is passing you, it doesn't look like it's going 100 km per hour anymore. It looks like it's slowly crawling past to you. To your eyes, it only looks it's moving with 20 km per hour. It's something like let's say in Olympic, if you are an observer, if the Usain Bolt and other people are running, like when Usain Bolt is running, for you it appears to be he is running super fast. But if you are running with him, it won't be that much fast like for an observer. So it would be little more like 20 km per hour. So that kind of a relative speed. So that is, we are talking about the relative speed. So this question is all about the relative speed. So when you want to calculate the relative speed, if the two objects are moving at the same direction, they are helping each other stay apart. So when you want to find out the relative speed, you can subtract their speeds. If the two objects are moving towards each other, the gap between them, that closes very quickly. So in that scenario, you're going to add the speed. So the relative speed is going to be V1 plus V2. So now let's see in this question. You can see, let's sketch the diagram. The question says, two cars A and B are moving in uniform rectilinear motion with the speeds of 120 km per hour and 80 km per hour. If at the initial moment A is 500 meters behind B, So you can see A is somewhere here and B is somewhere here. The gap between them is 500 meters. But the car A speed is 120 km per hour and the speed of car B is 80 km per hour. Now we have studied the relative speed. So we have to find out the relative speed of, so since they are going in the same direction, to find out the relative speed, we're going to subtract. So if you subtract this, the relative speed is going to be 120 minus 80, which is 40 km per hour. So this is, now you can imagine like the car B is perfectly still. In this, B is stillward and car A is driving towards B exactly 40 km per hour. So the question is whether it overtakes or not. So now it's like, now when we talk about the relative speed, you imagine the car is still, car B is still, and the A is moving towards with the 40 km per hour. But the question asks what happens after 1 minute, but the speed 40 km per hour is 4 hours. So what we can do is 1 hour, in the 16 minutes, it is 40 km, then 1 minute, 40 over 60 km, which is 2 by 3 kilometers. So if you convert this 2 by 3 kilometers into meters, it's gonna be 666.7 meters. But the gap is 500 meter. But during that 1 minute, A can pass 666.7 meter, so which is greater than 500 meter. So we can simply say A has overtaken the B. So in this question, you should be able to convert the kilometer per hour in terms of minutes, and also you should be able to have some idea about the relative motion. This question is very easy. These are very fundamentals, and the calculation is not that difficult, so it's going to be very easy. So while you are practicing for IMAT, also make sure that you are doing your questions by yourself, like don't depend on the calculators and all, because IMAT you're going to calculate by, you are not allowed to use the calculator, so it's better to practice from now onwards. So that's about this question. And now let's go to the next one. An electric circuit consists of 100 branches connected in parallel. Each branch has 10 resistors in series, each with a value of R. What is the equivalent resistance? So it's a very simple question. So it's really simple. Just if you understand this and if you simply apply it, you will be getting the answer. So let's talk about this series and parallel. If the resistors are connected in series, to find out the resultant resistors, we have to add the individual resistance, which is R1, R2, R3, R4. R1 plus R2 plus R3 plus R4 is R, which means instead of using these individual resistance, you can use the R, the resultant resistance. Now, for example, let's say this is not R1, R2, R3, R4. If they are similar resistors, with the resistance of R, means the resultant resistance is, like, let's say R, 2R, 3R, 4R. So 4 into R. So if you have a same resistors with the same resistance, so then it is going to be number of resistors multiplied by the resistance. So it is N into R. In the similar idea, if the resistors are in parallel, the resultant resistance is 1 over R is equals to 1 over R1, 1 over R2, 1 over R3 plus 1 over R4. So the resultant resistance, it's gonna be, you can subject R and you will get the answer. But in this case, if you assume every resistance are R, same resistance, so then the resultant resistance would be R over N. For example, like let's say you have a resistance R. They are connected in parallel, and then if you want to find out the resultant resistance is, it's gonna be R by 4 in this case. Now let's try to approach our question, the question which is given to in this question. you can simply understand there the question is saying an electric circuit consists of 100 branches connected in parallel. Each branch has 10 resistors in series. So this is very simple to understand. In one branch, you have a 10 resistors in series, and each resistors have a resistance of R. So then now only we studied if it is R and then R, likewise you have a 10 means the resultant resistance is 10 R for one branch. Now this kind of 100 branches are connected in parallel. So then simple idea is, if the 100 branches with 100 resistors with the resistance of 10 R connected in parallel, then now only we studied it is going to be R over N, the resultant resistance. So resultant resistance, now the R in this case is 10 R divided by 100, so it's going to be 0.1 R. It's a very simple question. There won't be any dilemma while you are solving these questions, and you know, like when you are doing this question with this accuracy, you really know, okay, I'm doing it correctly. So that's important here. So that is interesting to understand, and let's move on to the next question. Which of these particles move in a straight horizontal metal wire carrying a current from left to right, which is very fundamental. There is no questions to argue. Which of these particles move in a straight horizontal metal wire carrying a current from left to right? So this is your left side, this is your right side. Current from left to right. When the current is moving from left to right means, you must understand, this is a very basic principle and very fundamental principle. Usually the direction of the current is the direction of flow of positive charge. If the positive charge moving in a certain direction, the current direction also same. But you know, if the positive is moving in one direction, the electrons are moving in the opposite direction. So the first scenario, if you see the first example, first answer, only the electrons moving from right to left, straight away answer. If the electrons are moving from right to left, the direction of current is opposite to that, it's a straight away answer. You don't want to check the remaining answer, you don't want to waste the time, because the first one is 100% correct. You don't want to check the other answers and waste the time on it, because if it is 100% accurate, you don't have any dilemma, then you don't need to check the other answers and you are saving your time. So that is a very good idea. So you must understand the direction of the current is, it is a direction of the flow of positive charge. But the electrons, it is a negative charge which moves opposite to that. So the direction is the opposite direction of the flow of electron. It's a very basic principle, And let's move on to the next question. An astronaut takes a spacewalk at a distance from Earth's surface equals to 3 times the Earth's radius. What fraction of g corresponds to the acceleration experienced by the astronaut? This question is very simple. So when you want to, in this question, what is very important thing that you have to understand while you are doing this question is, you must understand the gravity is measured from the center of the mass. That's the fundamental thing you have to remember. The gravity is measured from the center of mass. Not the surface. So that is the simple idea. So now it's going to be very simple. So here you can see the gravity is always measured from the center of the mass. Now if you explore this question, it is very easy, and whenever you are solving these physics problems and all, make sure to approach it with the proportional idea. It is easier to solve. Now you see the gravity is proportional to the distance from the center of mass, which is r is, so g is proportional to 1 over r square. And then when the astronaut is, now you can see the astronaut from the surface, you can understand the astronaut from the surface is in the 3 r distance, 3 r distance from the 3 r distance, I mean 3 times the radius of the earth, that distance from the surface. So then from the center of mass it is 4re. So I can write g dash is 1 over 4re squared, because it is an inverse law, because gravitational strength is equals to g m over r squared. So g is proportional to 1 over r squared. So then you just write this down, and then g proportional 1 over r is r squared. G dash is 1 over 4r all things squared. Write it down and solve it, and you can see the gravity experienced by the astronaut is 1/16th of the gravity of Earth at the surface. So it's a very simple question. So here also we have to understand that fundamental. We have to know about the inverse square law. It's very important. And then also you must remember the distance is measured from the center of the earth. So that is something very important. And if you remember these two things, the mathematics part is very simple, so you can solve it and you can get the answer. And if we see the next question, the last question, the 59th question. A car with the mass of 2 times 10 to the power 13 kilogram travels in a straight line at a constant speed on a flat road. So first you have to understand the car is traveling 2 times. So the car is traveling, the car mass is given, which is 2 times 10 to the power 13, 2 times 10 to the power 3, and it is traveling with a constant speed. If it is traveling with a constant speed, means there is no acceleration. The acceleration is the rate of change of velocity. So here the speed is constant, the velocity is constant, so there is no change in velocity, so the acceleration is 0. Alright, so its speed is 15 meter per second. At a certain moment it accelerates with the constant acceleration of 2 meter per second squared in the same direction as the velocity. The constant frictional force is 2000 Newton. So the frictional force is 2000 Newton. If the frictional force is 2000 Newton, in the sense, if the frictional force is 2000 Newton, for the object to move in a constant velocity itself, the resultant force would be 0. So like let's say let's think about the two cases. The first cases, if it is a constant velocity, the resultant force must be 0. So let me say at that scenario the force is F1. So for the resultant force to be 0, we can say F1 minus 2000 must be equals to 0. So F1 is 2000 Newton. And the second scenario, it is accelerating with 2 meter second squared. So let me do it. The same car, 2 times 10 to the power 3 kilograms, and it's going with the accelerations of 2 meter per second square. So I can say we don't know the force, but the frictional force is 2000 Newton. So there should be a resultant force, then only there is an acceleration. So you can simply apply F is equals to ma, Newton's second law of motion. So F2 minus 2000 is equals to 2 times 10 to the power 3 times acceleration. So F2 is simply 2 times 10 to the power 3 plus, so here you can see the acceleration is 2. So 2 times 2 is 4, 4 times 10 to the power 3 itself. So it is 6 times 10 to the power 3. It is 6 times 10 to the power 3. So 6 times 10 to the power 3 means it is going to be 6000 Newton is the F2. 6000 Newton is the F2. So simply you can understand in this question, F1 should be 2000 Newton and F2 is 6000 Newton. It's a very simple. So Newton's second law of motion, and you should understand. If you really know the Newton's second law of motion, this question is, you cannot get the wrong answer for this question. It's a very, very fundamental. You should not make the careless mistake. Okay, so now let's move on to the question number 60. So this question is very interesting question. Mostly it needs a strong theoretical foundation, a theoretical understanding. A stationary liquid exerts on the walls of the container that holds it. So if I want to explain this question 60 simply, we focus on the nature of fluid at rest. So this question asks about the forces exerted by a stationary liquid on the walls of its container. On the walls of its container, like if the water is filled or if the fluid is filled here, how this fluid is exerting a force on the wall if the fluid is in a stationary state. So the answer is that these forces are always perpendicular to the surface, always 90 degrees to the surface. Just imagine you are leaning against a wall. If you are leaning against a wall, if you push straight into the wall, you stay still. But if you try to push the wall sideways while leaning on it, your hand might slide. The same idea, I mean, it's a simple analogy I'm saying. In a liquid, the molecules are, like, if you think of a fluid, these liquids, the molecules are like a crowd of people. If the liquid is stationary, not moving, it means none of the people are sliding past each other or else along the wall. It means none of the people are sliding past each other or along the wall. If the water pushed on the wall at an angle, the wall would push back at an angle. Because water is fluid, it cannot resist that sideways push. Otherwise, if you think of a solid, if you are exerting a force, there won't be any change in the shape. That is known as shear stress. But if you think of the fluid, if there is a sideways push, either it would start to flow or else slide. So since the question says water is stationary, there must be zero sideways pushing. The only way to have a zero sideways push, if the force is directed perfectly 100% straight into the wall. In physics terms, we can say this is a normal force, because if the molecules are exerting a force in this direction, according to Newton's third laws, there will be a normal force which is also perpendicular. So that's a simple idea. So this question is, what kind of forces does a stationary liquid exert on the walls of its container? But most of the students, they get confused between parallel or else perpendicular or else variable forces. The answer is always perpendicular. But I want you to understand why, so you never forget it. So in this case, if you think of it, if you read the word stationary, it means the liquid is perfectly still. It's not flowing. It's not swirling. It's just sitting there. So then there should not be any sideways force. If there is a sideways force, there will be a swirling. So it is no more stationary. The question says the liquid is stationary. If the water is moving, it's not stationary anymore. So the only way the liquid stay perfectly still is if there is no sideways force at all. The force must be directed exactly 90 degrees into the wall. This is fundamental rule of fluid statistics. You must understand, pressure in a static fluid always acts perpendicular to any surface it touches. Pressure in a static fluid always acts perpendicular to any surface it touches. It's a very simple idea. Whether it's a curved bottle, a flat tank, or else a huge dam, the water is always pushing straight out against the surface at every single point. So the answer is always perpendicular to the walls at every point. So this is for the 2025 IMAT Physics. If this series helps you, understand the logic behind the math and physics, make sure to hit that like button and subscribe to Study with Sri. We have a full walkthrough for biology and chemistry coming up next. So good luck with your prep.